Hi, I'm Zoe, and in this video we're going to be looking at examples of greater depth problems you can use to assess pupils' understanding of area and perimeter. Again, this is an area that pupils find really quite confusing, and the relationship between area and perimeter can be quite scary for them. Having a chance to practice this, to play around with it, lots of different examples should help them to firm that up. So here's our first problem. When the area of a shape is doubled, the perimeter doubles too. Is this true or false? Again, we've got a hypothesis. We've got a statement that we need to prove or disprove. The best way we can do this is by trying some examples. So I've just picked two rectangles. The first one had an area of 6 centimetres squared, 3 centimetres by 2 centimetres. A good opportunity to remind pupils perimeter, the distance all the way around, area, multiplying the length by the width. So here we can see the area is 6, but our perimeter is 10 centimetres. So what we'd like to see here, now that we've got an area of 12 centimetres squared, we're saying that our perimeter should be 20 centimetres. Well, let's have a look. Our area is 12 centimetres squared, so our length is 6 centimetres, our width is 2 centimetres. We can see from this our perimeter would actually be 16 centimetres. So it's false. Again, proof by counterexample. We've managed to say that we can't prove this, so therefore it must be false. Again, mixing this up for pupils, could they find an example where it is true? Could they find other examples? What happens to the area if the perimeter's doubled, for example? So again, lots of opportunities for pupils to investigate this. Moving on to our second problem. A little bit more in depth, we're looking at year 6 here. Joe has 200 metres of fencing. What is the largest rectangular area he can enclose with this? First off, we're wanting pupils to realise 200 metres is the perimeter of the entire rectangle. So therefore, halving this, the length plus the width must make 100 metres. So we're wanting pupils to find numbers that fit, length plus width makes 100, and then to realise our length times our width gives our area, and try to find the largest numbers that they can. Again, letting them explore various different rectangles so they can see the effect that the perimeter has on the area. We're hoping that as they go through this, they start to realise that the closer to a square they get, the bigger the area, because of course a square has a bigger area than a rectangle. And that is how we're getting pupils to think about that relationship between area and perimeter. So there we have it, 2 activities you can use with pupils to assess where they are with area and perimeter.